A huge welcome to BlocksUp, a huge welcome to today's Science Talk. My name is Pernille Berg, and I am today's moderator. On a daily basis, I'm also the Science Manager of BlocksUp, and it is such a delight to welcome you today. And a huge welcome to you who are with us in Copenhagen. It is really nice to see you today. The questions we ask in our series, Designing the Irresistible Circular Society, are relevant. How do we ensure a sustainable future? How will our buildings and cities be created and by whom? Which values and materials will characterize the society of today and tomorrow? Circular economy and circular built environment are high on the agenda, indeed. Because in Glasgow today at COP23, as we're here in Copenhagen, they are actually addressing the built environment. We've been working with the sustainability paradigm for a while now. It has guided transformation and reconfigurations of economic, social, and environmental aspects of our society. More recently, circular economy has become the approach used for creating systemic change. Moreover, there is also an increasing concern for social justice and inclusion regarding circularity. What can we learn from the sustainability paradigm, and how can a circular economy meet the human needs within the planetary boundaries? Those are some of the questions. So when we ask the question, how can sustainable paradigm guide us towards a socially responsible circular society transition, it is not just to address what is happening in Denmark, namely from 2023, we are required by law to conduct lifecycle analysis, but it's also to pose the question and go beyond that. Just how can this also assist us in ensuring a social sustainability? Now, before I will introduce our speaker of today, and I've been looking forward to welcoming Morten a lot, I'd just like to thank the partners that we're collaborating with in ensuring this series of events. Thanks to Arup, 3XN, Linear Group, the Royal Danish Academy, Danish Design Centre, and Build Aalborg University. Without a strong partnership, we're not able to do this. So a little bit about BlocksUp, because that's what we are about in BlocksUp. And those of you who have heard me say this before, bear with me. But still, for those of you who are with us for the first time, it might be nice to you to know where are we situated. We are in the city centre of Copenhagen. BlocksUp was established in 2018. It's a public-private partnership, and we live to ensure strategic partnerships and collaboration between research institutions, companies, and organizations. Because we believe that collaboration is one of the most vital ways to ensure the creation of a circular and sustainable society. We're about 700 research institutions, organizations, and companies who share our lives in BlocksUp, either as members or as residents. The thriving community can be seen in new research projects, networks forming, partnerships emergence, and new product development. We believe the new solutions to sustainable urban development come from consilience and collaborations. Science Talk, to us, is one important way where we can ensure the latest research mediated to you wonderful people, with us here physically and virtually. Morten is not just our speaker today. Morten is also the supervisor of one of the researchers in our network Circular Built Environment. So it's just one example of how we make sure that we collaborate in as many ways humanly possible. For you with us virtually, I can only recommend that you comment and pose questions in our chat. I have a wonderful, brilliant colleague, Rikke, with me as your chat hostess. So please feel free to comment and ask questions. We will address them later. And to you with us, please ask questions later on as I leave. I'll leave for Morten to present, and then I'll return so we can have a wonderful Q&A session. You will also receive a link afterwards. I'll get back to that. So, Morten, thank you for being with us.
Thank you.
You are on a daily matter assistant professor at DTU.
Yes.
You are also one of our leading experts on LCA.
Yes, in all modesty.
Yes. I'm not modest on your behalf, because you're actually specialized in environmental impact. assessment, business, and economy. So you know a lot about these planetary boundaries and life cycle assessment.
Yes, certainly.
So I will let you present, and I look forward to talking to you afterwards.
Great.
Thank you for being with us today.
Yes, thank you a lot for letting me present today, Pernille. Yes, so thanks to all of you for being here in person, and also for everyone here on the interwebs. It's so nice to have so many available. Today I would like to talk about how the new sustainable paradigm, how it can guide us towards a social responsible circular transition. And my name is Morten Ryberg. I'm from the Technical University of Denmark, more precisely from DTU Management, and I'm sitting at the section called Quantitative Sustainability Assessment. And normally I work with life cycle assessments and sustainability assessments. So a lot of this presentation will be about sustainability, because this is what I know something about. And this is my first image. So I'm trying to take you on a very small journey, at least on a small ship in the middle of the ocean. And this is really inspired by the great Ellen MacArthur. She was a professional sailor, and apparently this is where she got the inspiration for the circular economy. So you're in the middle of the ocean, and you have a voyage between two continents, for instance. When you do this, then you need to plan. You need to make sure that whatever you have on this ship is what you need, and there has to be enough for the trip, and there shouldn't be too much. So you need to think about your resource consumption. You need to consider that there's a finite amount of resources, so you cannot use everything on day one, and then you'll starve for the next many days on the ocean. So this is actually where circular economy comes into the picture. You have a closed system, like this ship, and you need to make do with what you have on the ship, because you don't have any other suppliers. These are the resources you've been given, or you have actually planned to have. And now if we use this, but just in a larger scale, let's say in a planetary scale, then we'll see the same image. This is one of the first images of the planet Earth that shows it as it's in its entirety. And it's from 1972, from the Apollo 17 mission. It's called the Blue Marble. It's really a great image. What I find striking about this is not just that the Earth is round. I think that's interesting in itself, but also that we see that there are no cords or cables or any other suppliers to Earth, which means it's a closed system, like a ship in the middle of the ocean. The only thing we get, besides the one or two meteorites or something like this, this is the solar influx. So we get energy from the sun, but besides this, it's a closed system. So all the resources that we have on Earth, they are the ones that we have. We'll not get more. We need to protect the ones we have, and we need to ensure that we have them in a sufficiently high quality. This means that we should not be extracting resources at increasing pace. We need to manage our resource consumption of metals, minerals, whatnot, to a level that is actually in line with, or actually planning for the future ahead, because we want to have enough resources also for future generations. In the same line, we don't want to spoil our natural resources, such as clean air, clean water, clean soil. We need this because we need these resources for our society to function and for us to feel good. So we need to also limit our emissions of carbon dioxide or toxic chemicals and all the other things we pollute the environment with. We need to take this into account, and we need to think about protecting our resources and the ones we have. And this is where we need to think in a circular economy or circular society. It's really about closing the loop, having our economy, our society as a closed system within the closed system that is Earth. So that's of course the ideal. When we look at how it is, the state of play and the trends, when we look at humans, then we see that we are getting more and more people. We are getting richer and richer, at least per capita. We can expect to live longer than the previous generation. And we also see something like child mortality is declining. So on a planetary scale, we're getting better and better. I mean, we're actually, of course, there are examples where we don't see a good development, but on a planetary scale, we'll get better and better. And that's very good, of course. But then when we look at the environmental side, we see well, it's the same type of curves, but the effects are negative. So actually, us getting better and better, more and more, richer and richer, it has a negative effect on the environment as it is right now. So we are emitting more and more carbon dioxide, creating climate change. We are degrading terrestrial biosphere. This means that we are losing biodiversity, and this is a huge problem. And we actually talk about we have a climate crisis. I think we know this by now, not least because we have the COP running right now, and then all politicians are going out and saying, well, it's worse than we expected. Well, maybe not, but I think we knew it was really bad. But apparently it's even worse, so that's not good. And we also have a biodiversity crisis. This is not as much in the agenda, but it is quite clear that we are pushing biodiversity. We are really losing species at an alarming rate, and we are talking about the 6th mass extinction. And that alone does not sound very good. And this is really a problem because energy, well, this is what we live off. We need the sun, we need this energy regulation of the earth. And biodiversity, well, this is the regulator of all life on the planet. And these two things, we are trying to push those. We are trying to disrupt these two systems, although this is the core for the stability of the planet. So we need to consider this, and we need to think about this. Not just because we want to protect the environment. I mean, that's beautiful in itself. We should protect the environment for environment's sake. But also because we need a stable environment. This is a figure from ice core samples showing what you see to the right. This is the temperature change, or the variability in temperature over the last 100,000 years. And what we see up until about 10, 12,000 years ago is that there were huge variability in temperature. I mean, right now we are talking about 1.5 to 3 degrees increase, and we talk about catastrophic events, extreme weather events. You know, societies will really be challenged. Here we're talking about 20 degrees. I mean, this is extreme compared to what we are talking about today. And this is, then you can see after about 12,000 years, we saw a stability in the system, so the climate started to stabilize. We don't know why this is the case. We just see that this correlates with the start of agriculture, the beginning of civilization, the building of society as we know today, where we are starting to get better and better. So while we don't really know why we have this stable period, we just know that it's good for humanity. So we should not try to push our Earth system out of this stable period. We want to continue this because basically this is the only period we know that we can survive in. We don't know what will happen if we go to a different state in the Earth system. So we shouldn't try to push our luck by pressuring the climate and the biodiversity. We should really focus on maintaining this stability. This should be the core, because we need a stable Earth to have a good society. We cannot live in an environment that fails. And to accommodate this, to achieve this, global society has settled on a number of goals. I'm sure you all know them by now. You see them everywhere, not least in these days. The global goals for sustainable development between 2015 and 2030. This is a set of goals. They are very nice. When we look a bit more at them, then we can say that the first 6 goals, they're really about humans. They're really about the increasing the welfare of humans, so no poverty, zero hunger, equality, really having nice and good conditions for humans. Then we have a number of goals, 13, 14, and 15, which are really about the environment. It's about the climate, it's about life below water and life on land. So you can say these are the end goals. This is what we want to achieve. We want to achieve good living conditions, welfare for humans, and we want to have a good environment with high quality. And then we have the other goals, and we can call these process goals or levers for transformation. So essentially, through these goals, we can achieve our end goals. So we can talk about clean energy, responsible consumption and production. These are not goals in themselves. These should be seen as process goals through which we can achieve our end goals, which is human well-being and a good environment. And most of these are driven by technology. So it's about innovation and inventing new technologies or improving existing technologies to ensure that we fulfill our process goals and thereby can achieve our end goals. And when we talk about technological development, then we can also talk about a sustainability challenge. I think we all know we have this, especially for the climate and for biodiversity. And often this can be expressed by the so-called IPAD equation that was developed in the 70s. Already back then we knew that we were in trouble. We were heading in the wrong direction in terms of the climate. So we have known this for many years by now. And still things are not happening fast enough. But the IPAD equation, it shows that environmental impact, this can be expressed as a function of the global population, the affluence, for instance, as GDP per capita, and then the technology, which expresses, called the technology factor, expressing the environmental impact per GDP. And when we look at this, well, we see that environmental impact, we know we have to decrease this. This is a goal. Population, it will increase in the future. We saw it from the figures before also. And we know that we'll get richer and richer, which are all good things. But this also means that the technology factor has to be reduced substantially in order to outweigh the improvements in population and affluence, and also to achieve the goals we have for environmental impacts. And the technology factor, the inverse of this, is what we call eco-efficiency, which is the value or the function or the product provided per environmental impact. And here is my focus is really on the technology factor. And here is an example for the the goals for improving the technology factor in 2030 in terms of climate. When we look at 2030, we need about 50% reduction in net emissions of greenhouse gas emissions, according to the different scenarios for achieving the 1.5 degree target. Then we need this. It has to be much more in the future, but let's start in 2030. That's difficult enough. And we'll know we'll be more people. So about 10% more according to UN projections. And we'll be richer, so that's great. We'll be 30% richer on average. And when we put this into the equation, well, then we see that the technology factor has to be 0.35. So that means that eco-efficiency actually has to improve by a factor 3 on average for all technologies in 2030. So this is a concrete target for technology and developers of technology, that this is where they need to head. And when we go to 2050, for instance, then we are talking about an improvement in a factor 10 or 20 actually, because we really need to reduce our greenhouse gas emissions. Yes. And then how do we assess eco-efficiency? That's the obvious question. Now we know we need to improve this, but how do we actually assess this? And this is where I believe I come into the picture, using life cycle assessments. So let's say we have a building here, a nice dwelling. We need to assess the eco-efficiency of this dwelling. So we know it has to be constructed. It needs to use building materials, building components to be constructed. So they have to be produced at some factory. In order to do this, then we need to have some raw materials coming from the Earth system or from the nature. So that could be different raw materials. It could be timber, it could be limestone, it could be gravel, all sorts of things, but they have to be mined and extrude, and then they will enter the factory. And then at some point, this building will be demolished after a certain amount of years, and then it will have to be treated, and part of it will go for recycling, so it might go into the factory again as a raw material. Some of it will go for final disposal, so it will go for incineration, creating energy, for instance, or it will go for landfilling, where it doesn't really do anything, but it just sits there, hopefully not causing any harm. But this is the life cycle of a building, and we can assess the eco-efficiency of this. And then we also need to have the energy, because that's quite important, especially how it is generated. And we need energy across the entire system. So we need energy for the building, doing its operation, for the factory. We probably also need energy for the waste treatment and for the withdrawal of raw materials. And then we have transport, not least. And in order to assess this, we need a system perspective. And the reason for this is that we want to include all the potential technological processes that are part of the full life cycle. And this life cycle, although it looks quite simple, then when you start modeling this and really looking into it, then you find out that this is really a system of systems. So we are talking many thousand processes. I guess this is one of the benefits of globalization, that we see everything is transported across and you have so many different stakeholders in every system. So we need to look at all technological processes and also look at all the relevant environmental impacts. And the reason for this is that if I do something about the energy consumption in the building, then maybe I need to add or produce more materials, insulation, for the building. And I need to be able to assess if the environmental impact related to production of the insulation is more or less than the gains from using less energy. If I emit more CO2 related to production of the insulation material, then I actually gain from reducing the energy consumption during the use stage, well, then it's not really a good decision. And I need to have this system perspective to evaluate if the things I want to do are actually good for the environment. And I need to look at all the impacts, because if I do something good for the climate, it shouldn't be at the expense of freshwater biodiversity, because I develop a new technology with very low greenhouse gas emissions, but then I just emit a very toxic chemical, for instance. That would be really bad. Or maybe it's good, actually. Maybe this is what I want, but then I just need to know it, because I don't want to risk that someone comes to me and say, well, you did something good for the climate, but all the fish, they are dead in the lake. Was that a good decision? Well, I mean, it's a political decision, but at least I want to know if I make this political decision. And in the end, we'll probably need this. So we want to avoid unintended burden shifting, and this is where we need this system perspective. Exactly. So for every process in our system, say you have a process, manufacturing, construction, whatever, there's an end product, but also for every process there's an exchange with the environment. So we need raw materials, chemicals, whatnot as input to our processes. We also often need energy. And out of the process we get emissions of different chemicals, CO2, toxic chemicals, whatnot, to air, water and soil. And we also have waste, and this also has to be treated. And all of these exchanges, they have the potential to affect the environment. And our objective is to evaluate what is the impact of this. So we need to look across all the different processes in the life cycle and evaluate their environmental impact. And we do this for all impacts that we can think of and all the ones that we think are relevant. So it's the global ones, climate change, ozone depletion, depletion of non-renewable resources, the regional ones, acidification, nutrient enrichment, we mainly see from agriculture, where we have eutrophication and oxygen depletion in lakes and streams. We have impacts on ecosystems and human health due to the emissions of toxic chemicals. And then we have air pollution, either from particulates or other photochemical chemicals like NOx or SOx that comes from combustion, for instance, in the cities where we have many cars. And we look at all of this. And we look at the local impacts, so clearing, transformation of land, loss of habitats for biodiversity, water depletion, and all of this we can evaluate for every exchange, for every process, and we can aggregate this to the total, and then we get the total impact for our product, the thing we are looking at and interested in, and then we'll actually get the impact per product. So this is the eco-efficiency. That's what I'm showing in this very nice animation. So these are the steps when we do a life cycle assessment, because this is essentially what it is. We model our product system, we get an overview of the life cycle. Then we have this called the life cycle inventory, which is a list of all the exchanges with the environment from this product system. And this is normally a few thousand exchanges, because there's a lot of things going on in the life cycle. And then we can quantify this and translate it into potential environmental impacts. And then we can start comparing, is product A better than product B? In this case, we see that the top one is global warming, and their product A has a lower environmental impact than product B. So if I'm interested in the climate, I should select product A. Unfortunately, we also see a bit later human toxicity product A is much larger than product B, which means that there's probably some chemical emission that's toxic to humans that's being emitted. So when I, as a decision maker, if I was one, I would have to make a decision about the climate or human health. And this is, of course, a political decision. This is why we can use lifecycle assessment. We can also use it more as part of eco-design, where I think it makes more sense, and actually open up our LCA to look into this human toxicity and see where in the life cycle, which process is actually responsible for these emissions. And then we can go into and look at this technology, this process, and see maybe we can replace the toxic chemical with something that's not toxic, or maybe we can just replace the process with an alternative or develop a better process that doesn't have these toxic impacts. So that's what we call eco-design, where we actually use life cycle assessment to improve our products. Now, just looking at eco-efficiency, that can be good, but it can also be, sometimes it can be a bit dangerous, at least for sustainability, because of these rebound effects. So this image, and it's the green curve you're supposed to look at, it shows the emissions in ton of CO2 per ton of steel produced between year 1900 and year 2015. And we see that we have a 62% improvement or reduction in the CO2 emissions. So we have a large improvement in eco-efficiency. So of course that's very good. But then we also look at the population affluence. We look at the global steel consumption. This has by far outpaced the improvement in eco-efficiency. And this also means that when we look at the total impacts, the total emissions of CO2 from steel production, well, then it is increasing. The only time we really see a decrease is during the oil crisis in the 70s, where we just stopped because prices were too high. So we had to reduce our steel use and our oil use, but we used oil and fossil fuels for the production of steel. So we saw something there. But this is where we need to take into account the global economy and the use and consumption of materials, because we cannot just look at eco-efficiency. So we need to move from what we call a relative sustainability assessment. So that is improving eco-efficiency, being more or having a lower environmental impact than the product last year, or having a new building with a lower impact than the other buildings next to the new building. This is what we call a relative sustainability assessment. So more sustainable than something else. Is A better than B? So same or more function with less impact. And we can show it like this. So this is our product, and this is our eco-designed product. And we can see it's getting better. So that's really good. But we cannot say if it is sustainable or not. There's simply no way to see this, because this is not a fixed axis. This is a fixed scale. This is simply just a relative assessment. So we need to move towards what we call absolute sustainability. So first of all, where is the boundary for when something is sustainable or not? This is, I think, where it gets really interesting and where we can actually start to see or make good decisions. So we need to introduce somewhere on this scale, we need to introduce a point and say, okay, this is where everything above this is not sustainable, everything below is sustainable. So in this case, the new eco-designed green product, it's better than the red one, yes, but neither of them are actually sustainable. So this is where we need to move. And now when we talk about the sustainable building, how does it relate to this? Well, I think, we know the global goals for climate. We all know the SDGs. I think most of us, we also know that the building sector is a major contributor to environmental impacts and to impacts on the climate. We have heard this many times. We talk about 30 to 40% of the CO2 emissions and also the energy use. So this is a major contributor. But we also see that the sector is getting better and better. So it keeps improving its eco-efficiency, which is really great, of course. But now we need to start working on this, and we need to think about how can we actually make the building sector sustainable in an absolute sense. And then, of course, when we talk about a planetary scale, how do these global goals, how do they relate to the building sector? I think there are many actors within this sector that would like to do something and be sustainable, but the question is often, well, how much do we need to reduce? When is better good enough? How good should a building be? Which path do we need to follow? There are many actors that would like to do something, but they don't really know how they should act in relation to the global goals. And this is where my claim is that when we talk about environmental sustainability, we should look at the science. We should go to the natural science and look at, well, what are sustainable levels of impacts, and this should be our starting point. So this is an image of the Planetary Boundaries framework. It's a framework that identifies and defines absolute boundaries for 9 core Earth system processes. So that includes the climate and biodiversity, but also other things such as use of land, freshwater use, emissions of nutrients. And the whole point about the planetary boundaries is that they identify and define what they call a safe operating space. So this is the green area in the circle. And within this, we're not pushing the Earth system. So we're actually minimizing our effect on the Earth system. And when we are in the green area, then we are in the safe zone. So we should be able to maintain the stability of the Earth system. Once we get into the yellow area, I have it here also, the yellow area, that's where we have a risk of exceeding tipping points or thresholds in the system. And as you can see here from the curve, this means that you might see a quick change in the state of the system. So you might go to a different state with lower quality. And the problem with this is that you cannot really come back. It's very easy to get there, but you have to reduce to almost zero to get there if you can actually get there. So these are irreversible changes. And the red zone, which we see for biodiversity among others, this is where scientists, they know we have exceeded tipping points. We have crossed thresholds. Now the goal is just to reduce and then hope that whatever we have done of irreversible damage is not so much that it will create an instability in the Earth system. So that's a bit of hope as well. But the green area, this is the safe operating space. This is where we need to be as humanity. So we can talk about a safe operating space, and this is for everyone. And then we can talk about a personal safe operating space. So each one of us gets an environmental budget that we are free to use on whatever we want to use it on, as long as we don't exceed it. And now this is for persons, so that's great. But how does it relate to companies or buildings? That's the next thing, and we have been working a lot on that too. And we want to assign a share. So we have our planet, our environmental budget. Then we allocate this down to the personal level. And then each one of our budgets, we can upscale this to industrial sectors, to buildings, products, whatever, based on the value they bring to us as humans. Because industrial activities, they don't have a moral right to any environmental space. They'll get their right based on the value they provide to us as human beings. So we can try to go in and look into buildings and see, okay, what value do the building have to me, and then how many users are there? And that will depend on the type of building. I mean, if it's a house where I want to live, then it has great value. If it's a hospital, then it has great value. If it's a new office building for a company I don't really care for, then it has little value to me. So depending on the type of building, its use, and the value it brings to the different users, then it gets a share assigned. And we can use this. And this is what we call absolute sustainability assessments. So we start with the environmental boundaries, then we can quantify the impacts using lifecycle assessment, and then we have an assigned share of the global boundary to this activity. And the equation is quite simple. The impact has to be less than the assigned share of the boundary. If it is less, then we can consider it to be sustainable in an absolute sense. And we actually try to do this also for buildings, because that was fun. So this is 5 houses called the mini carbon dioxide houses built in Denmark. And then we have one reference house, just to see if it makes a difference. And these are the results of our absolute sustainability assessment. And I would say the one to the left for climate change is the most interesting one, because that's where we see the major problem also. And it's striking to see that neither of the buildings are significantly better than the other. They all perform somewhat similar. They are about a factor 10 too bad or above what they should be. So actually, if you were a designer, decision maker, or developer of technology, then the goal would be to reduce or improve the eco-efficiency of this building by a factor 10. This is a concrete target. It's not just 5% better per year, something like this. This is something you can go out and you can work on this, and you know, well, a factor 5 is not enough. We need to reduce by a factor 10, and that's how it is. And if we do this, well, then we can consider ourselves to be sustainable. So this is how we use absolute sustainability assessments. And I would say there are 3 main strategies for achieving this. It's the area per capita, because if we live in smaller buildings, then we use less resources for building these or for constructing these buildings. So that's about the design by the architects, I would argue, and also the demand from the users. So we have right now the demand is that we need to live on larger and larger space, and we need to reverse this. Then we have material production and treatment. So we need to design, develop other materials that are more sustainable, and we need to look into maybe using other materials than we are using right now that are also more sustainable. So this is really about the technology developers and also about the designers when they select materials. And then we have the energy during the operation. So we need to reduce the energy use, and we also need to look into how do we actually produce electricity and heat, and this has to be done using environmentally friendly, low carbon solutions. And it's really annoying, but they are all quite dependent. So again, you cannot really just look at one of them. You need to have this systemic assessment and approach in order to make sure you don't do something for one of them that overall actually makes the situation worse. It has to be holistically evaluated to come up with the best solutions. So I would say we need to rethink sustainability of the built environment, move from the relative to the absolute, and then we need to move from having these bottom-up targets that we actually see we're having now from 2023. We are setting up targets for CO2 emissions from buildings, and these targets are based on existing buildings. Existing buildings that we know are not sustainable. I think that is problematic in itself. When we talk about sustainability, then the starting point should be what we want to protect. If it's about the climate, then we should start looking at what are the limits for the climate system, and then move this to make it relevant for buildings. Not start from something we know is not sustainable. I mean, that's pointless to me at least. If we want to protect something, then we need to use this as the starting point. Although it might be more tricky, but no one said it was easy. So we need to start designing with the intention to comply, respect environmental boundaries. So this is where we need to redefine the way we think about buildings, sustainability, and also the way we design buildings. And we need to use the existing building stock because it's already there. So using it again, that's basically for free. And it has to be done in a socially sustainable and inclusive manner. And I would say, to me, the most important thing is that if we want to achieve environmental goals, then everyone has to live in a sustainable building, in a sustainable house. We cannot just have sustainable buildings for the few. Then we'll not make it. If only the rich or the ones that have many resources can live in sustainable buildings, that's fine, but there are not that many people. So everyone has to have access to sustainable buildings. And this is why we need to expand it, also increase complexity. I love that. That's really always fun. But we need to think about this, the sustainability donut coined by Kate Raworth. And it talks about an environmental ceiling, the planetary boundaries, but then we also have a social foundation. And we need to live within the donut. So we need to have minimum social levels that we can achieve and still stay within our environmental boundaries. So this is what we call the safe and just operating space. This should be the goal. And when we talk about social sustainability, this is very, very difficult, I would say, but we talk about different dimensions. We talk about global sustainability, so I would say socially sustainable or responsible production of materials. It should be good, it shouldn't be forced labor, for instance, and ideally you shouldn't use child labor. But if you do, then you should actually empower the children by providing them with an education and giving them more resources to build a life on. So in that sense, it should be responsible. When we talk about local sustainability, it's more about being inclusive. It should be safe, accessible, affordable, good indoor climate, functional, and it should also create local jobs to improve employment. And here I would argue again, and this is a trend in general, that the system perspective, it is essential again to avoid that we have unwanted burden shiftings. Social sustainability, this is what we are working on right now, trying to operationalize this to make it a thing that we can actually assess and use to support decisions. And you can again define social sustainability as the physical needs. So this is basically what we need to survive. We need food, water. This is very quantitative. It's quite easy to put numbers on actually, because this is more physical. What is really hard, this is the psychological needs. So this is very much qualitative, subjective, relative. I mean, we had many discussions, or we have had many discussions in society about poverty, where you can talk about absolute poverty or relative poverty. And when we talk about psychological needs, it's really about relative poverty in terms of social sustainability. So this is, of course, very difficult to put numbers on, to operationalize, but this is where it gets really fun for researchers like me. And this is what we're working on. So we need to aim for buildings within the donut. And we know that they should not be for the few. They need to be for everyone, and everyone should have a sustainable home. And then we need to create a market for having these sustainability, social, environmental sustainability. And I believe that circular economy can be the answer to this. Because we need to create a market for this, and we need to create these local jobs to show that it is inclusive. And I can see that results show that circular economy and being more circular, this creates more local jobs because it is quite labor intensive, quite time intensive when we talk about reparation of materials, renovation, selective demolition, material recycling. These are things that normally take more time than the conventional demolition, for instance. So it needs more hours and more man hours. So that's great. And then I want to talk about transforming the building sector. I think this is quite tricky. Everyone always says this is the most conservative sector. And I don't know if it's true. I don't know all sectors. I don't think it's very conservative when it comes to it. I think it's quite innovative and really trying to do something. But there are some challenges for sure. It's really high complexity, and there's a lot of regulation also in the building sector, which makes it very, very complex because there's so many things you need to think about. And it's getting worse. We're also getting regulation in Denmark about CO2 emissions and CO2 limits. So we just keep piling on with regulation. It's characterized by many small actors, which makes it harder. There are many processes, there are many actors to track and follow when you're having a building project and managing a project. And having many small compared to one large company that drives the entire thing, that's much more difficult. And then because of the small actors, there's also a high focus on the costs. There's little profit margin. And when you have this, it also makes it harder to think about other things like sustainability. It's really about keeping your business. And then we see that these actors, they are also involved at different points during the building life cycle. Some are involved in the design, the planning phase. Some are in the construction. Some are in the operation phase, the maintenance. And some are in the waste management. And they don't really have responsibility for the others. So you might do something that's really good when you are constructing, but then it sort of it makes it really difficult to maintain during the operation phase, and that's where you see the problem. So we need to somehow consider the entire life cycle, or all actors have to think across the entire life cycle to make things that are easily to manage. And then there's little room for error, of course, because it is construction, it is things that we are, we are in, and we are trying to stay in there, and it shouldn't just fall apart. So there's little room for error. We cannot just test things and then it broke. That was a shame, right? I mean, it has to be safe, of course. That's really important. So these are my thoughts about what we need. I believe we need a collaboration across the sector, both in the building sector, but also linking with other sectors. Otherwise, we will simply not create the transformative change that we need. So we need to create a market for secondary materials and renovation. It's not really there by itself. We need some incentives, economic incentives, for creating this market for removal, repair, reuse of materials, and also for making waste handlers into waste suppliers, actually. And incentives for renovation compared to just demolition and building new. We need to use the existing building mass because it's there for free, basically, in terms of the environment. Then we need to create more technological solutions. We need cleaner production. So the materials that are already being produced, they need to do eco-design to make their production cleaner and have materials with lower environmental impact. We need to look into new materials, develop new materials, that are good for the environment. And then we need to also, and I think design for disassembly, it sort of goes across many places, but we need to consider that whatever we do, it has to be, we need to be able to disassemble again and recycle the materials. So this could also be a part of the secondary materials. But it is really about a technological solution as I see it. And then I think digitalization will be extremely important in the future. Like AI or machine learning for developing new products using less material but with the same functionality or durability. Just training the computers, the software to help us make the right decisions because they can do everything. Well, they cannot do everything, but all the things that we spend hours running again, testing new things, well, they can test 1 million things in a day, and then they'll show you the best solutions, and then it's just for you to decide which one is the best. So I think digitalization is definitely one of the ways forward. And then we have what I think is the most important one, the regulatory conditions. So setting the boundary conditions for the system, we need to have this. The market will not just drive itself. We need regulation. And we need to, and there's one of the bullets are missing. You'll get it in a moment, I hope. But we need this demand for lifecycle-based environmental impact assessment. So we need to take into account eco-efficiency, just as we also look at energy consumption. And then legislation, we need to, I think we have too many requirements, maybe too many standards or too much legislation and things we need to fulfill. We need to consider this and maybe look into, are there some barriers for sustainability? Maybe we can be a bit more lenient about some of the demands we have for indoor climate, for instance, or something else, because we have a goal and that is protecting the environment. So maybe we'll have slightly worse indoor climate. It will not be that bad, but then we can save the environment. I think we need to have this discussion. And I think that is a political discussion, but all the stakeholders from the industry, they need to be part of this. And this, then we need to, I think that's, for many it's obvious, but we need to think sustainability from the beginning of our building projects. This is a curve showing the development over time from the planning to the design to the sort of schematic design to the more design development in the BIM models and whatever, to the construction, and then until you have the building. And you see that the earlier you think in the changes like design for sustainability, the less it will cost you. The later you think it in, the more it will cost to change the design. And it's almost for free to start thinking about sustainability from the beginning. So we need to make it a part of the early design phase. We need to design our buildings using target value design, so where we actually design for sustainability. And then we need to get all the actors involved from the beginning. They need to be on board. They need to see what is their role, where can they actually contribute actively to be making this project more sustainable, to actually empower them. And these are my take-home messages after this lecture. I believe, and I think that's true, of course, the new sustainable paradigm, I think it provides us with a unique chance, actually, to redefine the building sector. I also see that there needs to be a joint effort across the entire sector, also linking to other sectors, but individually, one of the actors cannot do it alone. It has to be a joint effort, regulation, designers, engineers, construction workers, everyone have to pull together here. And then we need to start designing for absolute sustainability, move away from the relative sustainability assessments, and start looking at environmental and social assessments in a system perspective, of course. And then I believe, circular economy, that's at the core of this. We need to think about making it inclusive, and also the whole idea about the circular economy, the closed system, this is what we need to consider every time we start designing a building. And we need to create this self-sustaining economy and create local employment. Then the final thing, regulation, governance, I do believe it is key for creating the boundary conditions. Without this, we will not be able to make a self-sustaining market. I don't see it. We need to have some actions to set the right boundary conditions for the system to work. So with this, I would like to say thank you all for listening in. It was a pleasure to talk to you.
Thank you very, very much. Absolutely
You're
inspiring.
welcome.
And I think it's so nice that we are streaming this, because you are the first person I've met that says the industry is not conservative. So I think so many of us are happy to hear that.
Yeah.
Because it is credit that is due, namely that so many actors in the built environment are actually working hard every day to provide these sustainable solutions. But you're the first who've said it.
Yeah.
Thank you for that.
I'm not saying, of course, there are some conservative, right?
Yeah.
But we see that in all industries.
We've so much work to do, so we won't kind of rest on our laurels, as it were. But I just thought it was a very nice accreditation to give. So, and we actually have questions from people watching virtually. Thank you for that. And we will also have questions from you in here, I hope, participating with us in BlockSup. But from Robert Perry, thank you very much, Robert. The question is, how realistic is it to expect that at some point in the future, a global data hub will be available to provide decision makers with value impact data to help more informed choices?
I think it is. That's a good question. I think it is very realistic. I think we're seeing it all the time that data is becoming available. I think data is available as it is right now. It's just a matter of making it available for the ones that actually need it. And I think that's why we need digitalization to actually use cloud computing and Internet of Things and really driving this and making sure that we create this system. But definitely realistic. It will happen. Yeah. That's for sure. It's just a matter of who gets there first, I think.
And will it happen in time? Because I think also what you've provided with us today is that sense of urgency that okay, that's nice.
Yeah. I don't know if it will happen in time. I really hope so.
Yes. We'll stay optimistic.
Yeah, exactly.
So we have from Leonora Eberhardt, I'm pretty sure that you know Leonora, saying your slide showing that increased living standards, higher environmental impacts. How do we then lift underdeveloped countries? That is a very good question, Leonora. Thank you for that. I think that is...
Yeah, that's spot on. And I think that's everything about when we talk about social sustainability, that we need to consider everyone. And that is very tricky. And a very difficult question to answer, actually. I think what is needed and what has been talking about is having, again, collaboration, having the global society to work together here and maybe create these funds for development in low-income countries or something like this. I mean, we also see it with the with EU's new taxonomy, right, where they look into what is a green product, and then you'll have more incentive for investing in the green product. And I think it could be the same here. So there are different mechanisms. That's not to say that all mechanisms that has been, I mean, there are many of these low carbon mechanisms where you can do something or you can pay something and then it will go to developing countries. And I'm not sure they are really working. So there's this governance perspective that we need to make sure it's actually working.
Yeah, because Leonora continues and says, and do you think that developed countries have a responsibility for underdeveloped countries?
I don't know if they have a responsibility. It was a different time, I would say. So I don't really, it's a bit, and I mean, I'm part of a developed country, but I cannot really say what happened 100 years ago. I think that would be unfair to me, at least. But I think the global society has this, I mean, in any case, when we talk about the climate and also biodiversity, it happens globally, so it will also affect us. And if we don't help developing countries, I mean, maybe we see that also for steel production. They are using older power plants for driving steel production. They are actually the ones that mean that we have this stagnation in the eco-efficiency improvement over time. And of course, here, global society, the developed countries, they need to support developing nations into getting the new clean technologies, because we all have an interest in reducing CO2 emissions. So, I mean, I think it's also to protect ourselves.
Exactly. And I think part of the dilemma is that we usually see ourselves as the country providing a lot of solutions, that we have a lot of know-how.
Yeah.
But at the end of the day, we have used our share of the resources, sometimes even in February. I think this year it was in March. So we
Yeah,
have a
exactly.
lot of solutions, but our own behavior is not that recommendable, I would say, because we're actually one of the first countries to reach our limit in the year.
Yeah, exactly. We're really, I don't know, we're really good at emitting CO2 in Denmark.
We are, aren't we?
Well, at least our consumption is responsible for this. Yeah, I think there are two challenges in this. I mean, we need to, this is what they call the contract and converge, I believe. So we need to reduce our emissions to a certain level in line with our environmental budget. But the developed or developing countries, often they're actually not occupying their environmental budget. I mean, they have budget enough for emitting more.
Yeah.
So they should do that.
We have, I think it's time to ask if you have any questions or comments to Morten, because yes, we have Toge.
So great presentation and great that. Do I really need this? Okay. Oh yeah. So hi, great presentation and great that you bring in the donut model and focus on both the planetary and the human social boundaries. But isn't there precisely a risk of a burden shift from, you can say, the inter-environmental issues to something that has a negative social impact? To be more specific, you mentioned sort of the areas of impact and sort of area per capita. Unless you look at that through a social sustainability, a social impact angle, and kind of define a boundary there, there's a risk that you actually impact negatively on welfare, well-being, health, or other parameters around that.
Yeah, exactly. And I think that's why we need to have this system perspective. And I mean, it just makes it so much more complex all of a sudden. That's how it is, I guess. Things are complex. But I think we need to, and I don't have the answer, unfortunately. I really wish I did, because then all the problems would be solved. But we need to somehow design a system that is socially sustainable. I think that's really important, and that increases our welfare, but within planetary boundaries. But I also think we need to maybe question how we define welfare. I mean, in many places, Denmark included, we talk about welfare as our income, actually. And I think that's also just something that we have been taught over the years, maybe after the Second World War. I mean, we really started thinking about this as economy or economic growth being equal to welfare. And I think we could maybe start to challenge this a bit and talk about, what is the good life actually? Can you have welfare without having this large economic growth that everything seems to be depending on? And I think, so, I mean, that's a big question, and I don't have the answer, and I don't have the mandate to actually, do this. But I think this is the dialogue or discussion we need to take at some point. And I mean, time is running out. As every climate scientist are working with climate, things are going too slow, and time is running out.
Yeah.
We all say this.
Yeah. We have another question.
Hi. Thank you for a very interesting presentation. I'm wondering how we can overcome the rebound effects, because you say you focus on technology, and as we saw in the equation, we have like huge problems. Like, is it really the answer, eco-design, eco-efficiency? Because I mean, we haven't really gotten further when we look at it, and especially also addressing the social issues in that. So I was just wondering what your thoughts are on that.
That's a really good question. Yeah. Yeah, exactly. And we see the rebound effects, and it's a bit discouraging to be working with life cycle assessment, and you see that things are getting better and better, but it's actually not, because it often means that things are getting cheaper and cheaper. And if you talk about lighting, for instance, then it was very inefficient back in time, but we didn't have so much of it. Now it's super efficient, really eco-efficient also. We just use so much of it. So it's sort of, that's the problem. And we see the same with traffic. Beforehand, you had a wheel carriage with a horse, and it took a certain amount of time to go to Copenhagen from the suburbs. It takes longer time today, probably because you're just stuck in traffic, right? At least when you have to be at some place 9 o'clock in the morning. So I think that's a challenge. But that's where I think this absolute perspective comes into play.
Yeah.
Because there we actually we look at the market and we say, well, this is the market, or this is how a sustainable market would look like. And this is the share of a company or product on the market. This is the amount of users, and this is the value to the users. And then we can set an absolute target for this product. So it becomes independent of eco-efficiency. It just sets, okay, if you have this product fulfilling this function, then this is the budget you have, and you have to stay within this. And then, I mean, it doesn't matter if you produce 10 times more, then this is your budget. If you produce 10 times more, well, then hopefully you'll have more users, and then the market, and then it has to still provide the same value or more value to the users. But we try to take it into account in that way. But rebound effects, they're really tough. That's unfortunately.
Yes.
Well, I was just wondering, because you said that we all need to have eco-friendly homes. And one thing is to build new homes, but what about the ones that already exist? And if we're talking renovating them, how do we make that happen for people who might, own their own homes and can't afford that or live in public homes?
Yeah, exactly. And I think that's where regulation is needed, or some sort of governance to create the structures, the economic structures that allow one person to renovate their home. I mean, rather than, I think the main problem is that we see that we just demolish, perfectly fine existing buildings, and then we build something new. And then in 20 years, then we demolish it again, and then we build something new because now prices have changed and it makes more sense to build something else, or something like that. Or style has changed. And I think that's problematic. But we need to create the economic structure, incentive, subsidies, whatever, that makes renovation, the best incentive, also economically speaking. And it could also be that people with low income, they have a certain, they get part of the renovation funded or something like this. And I think we are in a wealthy society, at least. Denmark is, and many countries are, and we should have room for this. I think it should be possible. At least if we want to save the climate, then we need to do that.
And we actually have another questions from the audience, and thank you. And that'll be our last question today from Kasia. Amazing presentation. Thank you very much, she says.
Thank you.
The question is following the C2C certification for materials and products when we make choices enough? Or shall we make additional personal research on impact of these materials/products?
I would say that we need to do additional research. I mean, it's not, I think certification, also C2C certification is very good, and it's definitely better than doing nothing. So I think it's a step in the right direction. But just like any bottom-up limit or certification scheme, this will not lead to absolute sustainability. It will not lead to achieving the Paris Agreement, for instance. So it not to discredit C2C certification. I think it's great, but I think we need more.
Listen, Morten, I wish we had more time, but sometimes we have to stick with what we've promised, and that is from an hour's deep dive into a hugely interesting scientific topic.
Yes.
I think you also told us, or certainly inspired us, to think systemically. And
I hope so.
I would say you have done a formidable job at that. I also think one of the things that you leave me with for sure is that if we as people will not make the sacrifices in terms of becoming more wise, sharing the knowledge that we have, making the solution transparent, and perhaps accept, as Hapapikia studies say, that the next era that we are entering is the era of frugality, that we can do more with less, and in that way make sure that we can all enjoy life within the planetary boundaries. Such a huge pleasure. Thank you very, very much for being with us. It was really formidable. And to you out there, thank you very much. You have a link that Rikke has posted in the chat. Please, please, please fill out you open the link, answer our 2 very humble questions because your opinion matters. Hope to see you in 2 weeks where we follow up on this with a debate. We have a friend of us with us, namely Sid Hande from India, so that we are going beyond our scope of Copenhagen, because to do this, just as you say, we have to think systemically and globally, because that's exactly what our planet deserves. So thank you very, very much for being with us today. For you guys with us here in Copenhagen, thank you as well for being with us. It has been a real great pleasure. Thank you.
Thank you too, and thanks to all of you.